Right, good afternoon, everybody, and welcome to the MBRA EV webinar. Today we're talking about electric vehicles, and it's quite a comprehensive webinar, so there's lots of content, and it's a very important subject. So you have to excuse the slides, but I think you'll appreciate we've got quite an extensive knowledge base on the panelists this afternoon. We have Steve Hodgson, business commercial technical trainer and assessor from Automotive Training 2000, when he joins Pat in a minute. And we have Pat Doherty from Training 2000, who is also a technical assessor trainer. We also have Dean, the Industry Knight Lander, head of repair sector services from Fatcham Research and chair of the SV20 committee. And he's also on the board of AutoRace. And we've got our one and only Jerry Braddock, technical manager from the MBRA. So welcome, and I'm just about to put the presentation up to show you. So on today's agenda, we want to be covering understanding electric vehicles being rolled out at an alarming rate, and we got some statistics on that as well. Charging challenges for body shops, and we have a couple of polls. First poll in between that and EV training. So electric vehicle training, which training do you require? Who does it apply to? And how do you become compliant? We have a second poll, and then we have a return on investment and unlocking work volumes for the body shop in regards to electric vehicles. We're also going to touch on LCV and commercial vehicles and how they're emerging into the marketplace with EV technology. And then we're going to have a brief look at the future. So what other fueled vehicles are coming on or going to emerge into our industry over the next 5 to 10 years. And then we have a Q&A. So if you want to pass your questions through as we go on, then please do, and we'll do our best to answer them. And if we don't answer them during the webinar, then we will at the end of the webinar. So let's have a look at what types of electric vehicles are in our industry at the moment and the history and progression. But most importantly, in 2030, there's going to be a stop on manufacturing internal combustion engines. So this is a journey that we're all going to participate in, and we haven't got a choice. Yeah, electric vehicles are the future, and they're imminently coming into, if not already in the body shop, and the volumes are increasing at an alarming rate. Jerry, would you like to talk us through the different types of electric vehicles?
Yes, well, we all are well aware of conventional internal combustion engines. They've been with the industry for over 120 years. Toyota then brought in the first mass-produced hybrids, the hybrid electric vehicle, which consisted of an electric motor, a high-voltage battery, and a backup petrol internal combustion engine. And this has been on the go since 1999. Then there was the development of the plug-in hybrid electric vehicle, which had an external plug for mains charging. This gave you the advantage of overnight producing enough electricity to drive off on your commute for pure electrical drive for somewhere between 10 and 30 miles, depending on the conditions. Then we also have the two electric vehicles. We've got the extended range electric vehicle, which has a backup internal combustion engine in most cases, a small, very efficient unit. It's there purely to recharge the battery and give you an extended range. And then, of course, the electric vehicle, which is a battery pack normally underneath the floor of the vehicle, which will give you a range, depending on the manufacturer, of anywhere from 100 miles to up now 280 to 300 miles. This is charged externally from either a charger or from the mains. And that's where we are at the moment.
Okay, thank you, Jerry. So the extended range EREV then, that doesn't need plugging in. That generates the electricity from the braking system. And do you want to
Well,
just talk
the extended range, if I use as an example, the BMW i3,
Yeah.
you can buy a BMW i3 fully electric, or you can buy it with a range extension engine. The fact of the matter is, they still recommend that you plug it in and charge it overnight.
Okay. Thank you. We're going to go through some more detail on the specific technology within these vehicles. So the first one firstly, we're going to look at, obviously, the technology which has just come through from Jerry, which he's just talked about. And excuse me a minute. There you go. So we're not going to read this word for word. This is just for you to look back on when we post this on the NBRA website. And then we have the mid-strong hybrid electric vehicle. And Pat, would you be able to give us some information about this one? Give us some technical detail.
This was the. Can you hear me? Okay, yeah.
A little bit.
Yeah, that's good. Okay, right. So this was we could sort of say the first generation of the hybrid vehicle. The mild and the strong, as definitions, would be if we took, for example, Honda, who took the notion that the internal combustion engine would be the prime mover driving the wheels, and the electric motor would be the assister. And in which case the electric motors were only about 10 or 15 kilowatt motors on those vehicles. That tended to fall into the mild hybrid, which were small powered electric motors. The strong hybrid is very similar to what Jerry was saying about the Toyota Prius, where the motor might now be about 50 kilowatts. So that's a strong hybrid. One definition, and we'll come to this a little bit later as I have a look at the presentation, is that there is now another definition for a mild hybrid, which falls into the 48 volt bracket. But we'll come to that when we get to that slide, So primarily these are full high voltage hybrid vehicles. The voltage of the battery can be anything from 115 up to 300-400 volts, something on that notion. Toyota, with the Prius, cleverly decided to use a smaller battery, 201.6 or thereabouts for the Generation 2 Prius, but in the inverter converter used what they called a booster, and that would lift the voltage to over 500 volts. So that's why the Prius has a smaller battery than you might see on a Nissan Leaf or something, Anything else you want me to expand on that?
No. So with a mild and strong hybrid HEV, then it's still not the safe vehicle. You still need precautions. You still need to be safe around this vehicle. Okay, that's just something I wanted to clear up.
Yeah.
So the next slide is the plug-in hybrid EV PHEV, and probably the most well-known PHEV would probably be the Mitsubishi Outlander. And a lot of these were sold over the last 5 to 6 years. There was a lot of tax breaks on these vehicles, so they were very popular. I'm not sure how many got charged up. I think a lot of them got used with just using the engine, but it's where you can put either petrol or diesel into the fuel as your main component for drive, and then it can be topped up with electricity, and it's probably got a range of around anything from 15 to 25 miles. And if it's anything like my wife, she's got an Outlander PHEV, but she very rarely charges it up unless I plug it in. So, I mean, they are common, and you've probably seen these in your workplaces. And again, this is another vehicle that needs precaution when working on. So the last vehicle we're going to look at in detail is the electric vehicle. And Dean, would you like to give us a little bit more information on the electric vehicle?
Yeah, sure. Well, there's one thing that you need to bring out around this. You've just shown 3 different variations.
Yeah.
Every vehicle has some commonality about them. So you're seeing the DC converter, you're seeing the traction battery pack, you're seeing charge ports or not. You're seeing onboard chargers or not. Those things are the difference between plug-in hybrid and self-charging hybrid and electric motors. But fundamentally, the key thing to remember here is a high voltage system on board is a high voltage system on board, no matter the size or capacity of that system. And every one of the 3 vehicles you've just demonstrated all have high voltage systems on board, and therefore require special treatment and special handling through the repair business.
Isn't that under any special circumstance if you're doing a deep structural repair though? I mean, if a customer brings their electric vehicle in and it's just got a small dent in the door, so I want to DA that off, pin pull it, get the dent out, filler it, finish it, put the infrareds on. That's safe, isn't it? I don't need to sort of do anything special with that, do I?
No, I think it's extremely important that you understand the setup and structure of your high voltage system within that vehicle. Understand whether there has been any damage created to that high voltage system. You don't want to create heat or excessive electrostatic discharge in an area where a high voltage system has presented any damage, because you're just going to put your business and the people within your business at risk. This is the thing that I really want to get across here is that high voltage electrics is completely different from the 12 voltage electrics that the repair business would traditionally be used to dealing with.
Yeah, and even the 48 volts is going to pack a punch. May not be lethal, but it still injure you, and it still needs to be dealt with in a very particular way.
Yeah, when we get there, you'll see many manufacturers within their methodology are specifying the same safety protocols for a 48 volt system to a 60 volt plus system.
Okay. Any more on that, Dean?
No, that's fine.
So on an electric vehicle, then, I know the Jaguar 4x4 came out probably about 3 or 4 years ago. What was the typical cost of a new battery when that came out then? It was probably around...
Yeah, it can traditionally make up around 50% of the vehicle. So it's not just any one specific brand. These traction battery packs, especially for a full electric vehicle, are very expensive component parts of the vehicle. Jaguar I-Pace at launch had a battery pack with a value of 35,000 on a vehicle that was just under 70,000 retail price.
So that's going to make your eyes water if you need to replace one of those. And I know we've not touched on this, but there's 2 different types of battery packs. You've got one that's air cooled and one that's liquid cooled. Yeah,
the cooling solution is a strategic decision by the vehicle manufacturer in their design house. But it should be treated no differently. The cooling system on board or cooling system off-board is still a cooling system that must be treated and handled in an effective way around the battery. Without that cooling system operating properly, that battery will overheat and there will be undoubtedly a combustion incident that kind of occurs.
Okay, cool. Thank you very much. And high voltage vehicles charging in the workplace. So electric vehicles, this is coming to the body shops, whether we like it or not, it's going to be coming in for a repair. And the way we deal with customers is going to change as well. So, customers' cars coming in for repair, they're probably expected to come back with an element of charge in the vehicle rather than, 10 minutes down the road. Courtesy cars, if you take on electric vehicles that are courtesy cars, the whole dynamics of courtesy cars will change. And then employees that come to work in an electric vehicle may want to charge their vehicles too, which, that's a hell of an infrastructure you need to then think about for your body shops. And then who pays for the charging? It's not fair for the body shop to foot the bill for this. And then the turnaround times for the courtesy cars are going to be different as well. So if you've got a courtesy car at the moment, you probably get it back in. If you're busy, it's a wash and a vac and it's back out again. But if it comes back with a depleted battery, that means you've got to spend at least an hour to an hour and a half on a fast charge to put some charge back in the vehicle before you can give it to the customer again. And there's site electrical surveys you'll have to undertake to see if your electrical load capability or capacity is fit state to do the infrastructure which you want. Jerry, have you got any points on this?
Well, the point that springs to mind is that if you have external charges, you then have to make the decision as to who's going to pay for the use of that charger. And obviously, if it is external, you can put a card swipe device on it so that customers can pay for the charge. You can also buy a charge point that has the ability to cover 2 bays, so you can put 2 vehicles in 2 bays and charge 2 vehicles at the same time. If it's internal, you've got to consider that if you put it as a fixed charging point in the workshop, you are causing a bit of an inconvenience because that bay will be considered solely for use as a charging bay. It is possible to have mobile charging units that plug into your welding 3-phase, and then you can charge that vehicle in any bay that you wish. But these are all points that you've got to consider. Is the electrical system in the business capable of delivering? Have you asked the right questions and selected the right type of charging point for the business? And you know, have you made all the calculations about who is going to pay for what, and how much are you actually going to charge?
So this could potentially, if you've got enough land around your body shop, potentially be good, because you could obviously sell some of this services to other business in the surrounding area potentially. But we have supplier members of the MBRA that would be able to assist with some of these services. So if you are interested, please get in touch. And then off the back of that, if you get a damaged electric vehicle that comes in, what's the protocol for, you know, quarantining these vehicles? If it comes in and it's hit the curb, scuffed over, and there's scuffing to the bottom of the battery, what's the chances of thermal runaway and the risk of, you know, you parking this vehicle up unaware it needs to be quarantined and then getting a call in the night to say that you've got an inferno raging away?
Well, you know, if this vehicle that you're talking about has had a major impact, front, rear or side, or indeed something, it's gone over the top of something, you have got to put a question mark against it, and you've got to consider that you've got to put that isolated in a bay with plenty of space round about it, just in case there may be a problem.
Okay.
However, if a vehicle just comes in and it's got a scrape or a mark on it or a minor cosmetic repair, you just need to make sure that that vehicle is shut down properly, certified has been shut down, and rework on the vehicle and then open it up again.
So really you need a criteria to assess the vehicle when it comes in to see whether there's a risk for it needing quarantine or not. And I know, Dean, we've spoken about this previously, and I think the common sense of this would be, if you've got to quarantine a vehicle, it's got to be in an area of about 6 parking spaces or bays for it to give it enough room to. Do you want to elaborate on that?
Well, I think it's very important here to stress the point: you must seek out the manufacturer's guidance and information on isolation. We've seen in our research some pretty extreme quarantine procedures, and some very reasonable quarantine procedures. I think the biggest challenge that the repair community will face in these circumstances is actually right now a lack of information. And that's something that Thatcher and Research are working with vehicle manufacturers to try and overcome, because it's critical key information. If there's any damage to that HV system, quarantining to prevent any ongoing concern happening, and to prevent personal injury is key to safety.
So another one off the back of that, then, if you get 3 vehicles that need quarantining, that's pretty much a car park full, isn't it? With 3 cars.
With the right cars, yes.
The right cars, yeah.
But that doesn't,
so potentially a solution for this would be for the recovery agents to take that problem away from the body shops and only deliver the vehicles when it's safe to do so.
Well, I think you've got to consider, of course, in all this, is if a vehicle is in a road accident, an electric vehicle and it has an impact, there are sensors and devices on the vehicle to shut down the high voltage system during that impact. So it is normally, unless the battery is damaged, it's normally immediately safe for the first responders to lift onto a recovery vehicle and take away. But they've got in the back of their mind to worry about possible damage to battery packs, etc.
That's the problem, isn't it? The
That's the
exception that
problem.
causes the issue. So that's a problem for another day. But
Yes,
this slide is just to elaborate on the future and potentially what you need to be thinking about in, you know, dealing with EV vehicles, not only for repair, but actually dealing with the customers and their requirements as well, and the safety. So poll 1, our first poll. So if you could all participate in this, and the first question is, as a percentage of total vehicle sales, how many EVs do you think were sold in the UK in 2020? So was it 0 to 10%, 11 to 20%, 21 to 30%, or above 31%? Second question, how many variations of EVs are there currently? So Jerry elaborated on this on the earlier slide. Was it 1 to 2, 2 to 3, 3 to 5? And have you repaired one of these electric vehicles, whether it be mild hybrid, electric vehicle, extended range vehicle? And a very important question at the bottom, have you heard of the electricity at work regulation? And do you adhere to it? And be completely honest, if you have, brilliant. If you haven't, no issues. And if you're not aware of it, then, you know, we need to do more awareness on this. Give that a second just for the results to upload. So there you go then. 0 to 10, 11 to 20. So it was actually C, 21 to 30%. On the first question, how many variations of EVs are there currently? 3 to 5 is the correct question. Answer rather. Have you repaired one of these models? So there's quite a high percentage of you that have. And not sure is another worrying one, but again, that's why the webinar is today, for the awareness. Have you heard of electricity at work regulation and do you adhere to it? So 42% of the panelists or attendees say yes, 13% no, and you're not aware of it at 46%. So there's more education needed there. And I thank you for being honest on that one too. So we will talk a little bit more about the electricity at work later on in the presentation. So 48 volt mild hybrid. You know, this is a stealth technology that's coming into the marketplace at a rapid rate of knots. And you can see on this slide, you've got the Fiat Panda, you've got the Ford Fiesta, the Kia Sportage, Suzuki Vitara, the T-Roc. They're all bread and butter vehicles that are coming into the body shop. It's no longer is it the A8 or the Bentley. It's, you know, very common vehicles that are adopting this technology. Dean, how do you see this playing out?
Well, 48 volt technology is an interesting one. It's being brought in rapidly to kind of support some of the other technology that's being fitted around the vehicle. Most commonplace, the 48 volt system will operate stop-start technology. But it's also being used by vehicle manufacturers in all sorts of ways to help operate the adaptive lighting systems that are now on board. The position of the 48 volt system is not common either. You can find the battery pack for the 48 volt system anywhere around the car, depending on the model variant. And as you've already stated, the model variant on the market today are already quite significant, and that's just going to grow over the next 2 to 5 years.
So 48 volt seems to be a bit of a buzzword at the moment. Pat, would you be able to walk us through this next slide, which has got more of the technical features of the 48 volt, and something close to your heart, I know.
Yeah. Essentially, why this was brought in, as I understand it, was the manufacturers of engines and all the rest of it developed over the years, and decided they would build 48 volts. So we've got Steve now that's joined us.
Yeah, got that.
Okay, right, okay. So the 48 volt system, as we said before, is a safer system in terms of the voltage thresholds, where we say that 60 volts DC is the maximum, above that is the maximum safety threshold. So 48 volt is deemed to be less dangerous than the higher voltage systems, which is why we don't see yellow cables on these vehicles. And when we do quite a bit of the training, we do find that a lot of the trainees will say, we have seen vehicles in the workshop that's had a hybrid badge on the vehicle, but we've not seen any yellow cables. So the knowledge of these vehicles to me is not that common, you know. So we have the petrol or the diesel hybrid, or we could have, I've not personally seen a plug-in, but that doesn't mean they don't exist. And I've not seen or heard of a 48 volt with the fuel cell, but of course they must be coming on and must be existing. Every hybrid or electric or alternative fuel vehicle has a 12 volt system additional to the high voltage, whether it be 48 or above. I think there is a lack of knowledge in this department for the knowledge of these vehicles, you know, through workshops, trainees, etc. So this is one of the things we bring to the forefront when we're actually doing the training course. We explain about these 48 volt systems.
Okay, so Pat, on this, so you've got a stop start on the system on the vehicle.
Yes.
So 48 volt.
Yeah, the two main systems that we have for the 48 volt are, I'll use the Volkswagen acronym as a BAS, which means belt alternator system. So you've got what essentially is a huge or a very large alternator starter motor bolted to the engine itself. So this assists with the driving of the vehicle. In other words, when you want to accelerate away and the ADAS or the radar system locks onto the car in front, then the belt alternator system will assist the engine in no delay when you actually put your foot on the accelerator. The same rule applies. We have regenerative braking, and during how the CO2 emission levels can be met with the, in the case of the Audi A6, a V6 TFSI twin turbo engine, is that these vehicles will cruise or coast when they are going along. So the system is switched, the engine is switched off. And the system, the 48 volt system monitors all this type of system and would again start up the belt alternator system should it need to charge. The only difference to that system is the Mercedes-Benz, where the electric motor is driven off the or is off the flywheel end of the vehicle. In other words, if it's a rear wheel drive, it would be in the gearbox housing driving the rear wheels type of thing, you know.
Yeah. So on these, sorry, Pat, on these systems, if you've got adaptive suspension, that could be driven by 48 volt now.
Yes, most of the systems are driven off the 12 volt, as in every other system. The 48 volt system could drive electric systems. The other thing that I think Dean mentioned before was about the cooling of these systems. We now see an integration of this within the air conditioning system as well, being part of the battery cooling to do with that as well, you know. So the 48 volt system is primarily to do with the charging of the system and being a backup system. And of course we have a DC to DC converter to step it down to the normal 12 volt for all the other systems that needs to run on the 12 volt system.
Right. So what's the danger here then? Because 48 volt, it's not lethal.
No, and you'll find that these are either blue or light blue cables that are in these vehicles, which is sort of a clue to it not being orange, if you know what I mean. But having said that, there is the potential. We've sort of looked at the EV, electric vehicle, which is part of what the main thrust of your seminar. What we must be mindful of as well is on hybrid vehicles, or mild hybrid for that matter, that engines can start up at any time to charge. Yeah. So mechanical work or whatever you were doing on them, putting a pulley belt back on or something, could lose fingers. So it is as important to think about hybrid as well as EV, although that is an important characteristic,
Yeah, no, that's a valid point. I mean, I was talking to Pete Eden yesterday, and he was talking to me about a job that he was looking at in a body shop, and one of the technicians was testing the window. He'd obviously turned the ignition on, at some point started the vehicle, and the engine had stopped. A VDA had come out to take some information from the engine bay, and because the battery had dropped below a minimum charge, the engine started up again, and it caught his tie, and he's all right, but it was a bit frightening for the poor bloke. Yeah. So I think, the awareness, and you need to know what you're working on, and you need to know the procedures of working with these vehicles. So thank you very much for Pat on that one. Have you got any more info, or are you all right on that?
I think we're okay with that. I mean, the figures that we see is somewhere around about, there's going to be 2 million of these units spread across the manufacturers base over the next year or so. So we're going to see a lot more of these in the workplace,
Yeah, absolutely. And like we said before, they're not making a big show and dance over this. They're just coming in to the industry. All right, thank you, Matt.
Thank you.
I think one of the key things just on that while we're there, Tom, is that we've got to ensure that repairers don't think a 48-volt system is purely a stop-start system.
No.
48-volt systems are being used by different manufacturers for various different reasons. I mean, Audi's a prime example to take. They're using the 48-volt system to manage an electrical anti-roll bars in their A6 range, etc. That component part now is a very important part within most repair procedures of anything to do with structural, and it's now an electrified 48-volt system. So it is critical for repairers to understand this. And operating voltages of 48-volt are far greater and can be dangerously lethal if they're at full operating power.
And it holds a charge, right? So it still needs to be discharged. So, and I think you're absolutely right, Dean. There's multiple ways the 48-volt systems can be used, and I think they're testing out using them on turbos as well. So, making cars more efficient or quicker, one of the two. But yeah, no, very important point. So, what do I need to do to be ready? I mean, this is the big question. I mean, what do body shops need to be EV compliant and to safeguard everyone in the workplace? Dean, would you like to talk to us about this one?
Yes, I can do. You've already mentioned in your poll the electricity at work regulation. We know that the government aren't looking to regulate in this area of maintenance, service and repair of high voltage electric vehicles. However, HSE have been absolutely clear that the electricity at work regulation does apply to any business that's working on high voltage systems on vehicles. Yeah. Therefore, business has to be aware of this, because it's the potential cause for closure of business if something happens. One of those unfortunate incidents does happen on site, then directors can wind up in court. Businesses can wind up being seriously harmed financially and reputationally. But I think more significantly, staff members' lives can be lost with high voltage systems.
And that's yeah. I mean, you can't stress that enough, can you? Reference to the electric vehicles. It's we'll move on to that in a bit though. So yeah. Absolutely. And on the MBRA website, we will be putting more information about the electricity at work regulation, because it's clear to me today that it needs more awareness. Sorry, Dean, crack on.
Yeah, no, I mean, that's it. I mean, familiarise yourself best advice I can provide to any repair business: familiarise yourself with that regulation. Ensure that you've got the right tools, equipment, PPE around. Signpost the presence of EV vehicles everywhere, and train everyone in the risks associated with HV vehicles. Please don't just leave it to one qualified technician to be responsible for making everybody in your business safe around a HV vehicle.
Yeah, I mean, we've got more slides on the training and various levels of training, which Steve will take us through. So investment in the right tools and equipment and PPE then. So we've got some costs on those on the return on investment moving forward, but the PPE is very important. Reference electric vehicles. It may not sound important. And I think, Jerry, you were talking to me yesterday about the quality of gloves when dealing with different EV components. And then signpost the presence of HV vehicles in the workplace. Why not? Why not put a big red flipping A4 poster on it to say it's an EV, so everyone walking up to the vehicle knows exactly what they're dealing with. And I know what you're going to say. An EV vehicle should be guarded, should be put in the right place in the workshop. And, you know, if that's happening, brilliant. But we need to make it very obvious the awareness that's needed to work with EV vehicles, and train everyone in the risks associated with HV vehicles. And we'll move that through the next slides.
Tom, can I just add that obviously with the PPE, it might be worth contacting their individual suppliers, because a lot of tool suppliers do provide full kits for HEV, PPE signage, everything. Tools and equipment.
No, I think it's a good point, Steve. I mean, there's workshop kits with a barrier. You've got the shepherd's hook to pull people away from a vehicle where it's gone wrong. There's lots of bits and pieces you need to invest in, but we'll come to that in a little bit. And Dean, you allude to catastrophic loss of life. It's so important. I mean, you can't put a price on that.
No, but let's be absolutely straight here. PPE is a last line of defence, not a first line.
Absolutely.
Oh yeah. Awareness is your first line. Absolutely. So moving on to hybrid training levels. Steve, do you want to give us a quick?
Yeah, that's fine. Yeah. I think one of the main factors to determine with training your staff is to determine at what level and who needs what. So obviously you've got your non-technical staff who may obviously be in the area of HEV vehicles, whether they're in a state of repair or not. Your front of staff, valeters, you name it, who may be involved with these vehicles, even if they're only moving them. But obviously they could be in a state of repair within the workshop that they're walking through. So they need to be totally aware of the dangers of an HEV vehicle. Obviously then you move on to your technical staff. Now this can be certain varying degrees within a body shop. You might have your painters who obviously aren't going to be heavily involved in any HEV system. They are working on vehicles that may have been shut down, may not have been shut down. So again, very high level of awareness needed. Same with panel guys. Obviously your MET staff are going to get heavily involved. Maybe only just safety shut down and reinstate. But they may then move on to be an HV specialist, where they're not only disengaging the high voltage system and reinstating the vehicle at the end of the repair, they may be removing and replacing high voltage components. So it really is key to engage your staff at the right level.
Okay, cool. And that's an overview of the next slides, actually. So
it's good.
It is. So awareness for all. I mean, it's become very obvious to me that it's not just your techs that need to be aware of electric vehicles. So from your receptionists, they need to know what's coming into site. I think, Dean, you've got a good analogy about someone sweeping the floor, haven't you?
Well, kind of, but not many people like it. But human nature tells us if we see somebody that we are close to in harm's way, there's amount of feedback on there. I can't. That's better. So human nature tells us if there's somebody in harm's way and we know them and they're a friend and a colleague of ours, our first port of call is to run to them to help them out. if you wind up with an ill-informed workforce running towards a high voltage technician who's made a genuine and honest mistake, you're just going to create a long line of catastrophe. Whereas good awareness for all, good awareness of how to act in the event of that unfortunate incident can save your business from a catastrophic event. I'm not going to use the conga line story. It doesn't work.
That's all right. Well, I can use another one. So when I was an apprentice, you take the ignition lead off a spark plug, grab the hold of the person next to you, stick your finger in, he gets a shock, everyone's laughing. But this is a much more serious event. If you hold on to someone that is in catastrophic trouble, where they've touched something on an EV vehicle, and you go to rescue them, you touch them and you take on that problem. We're talking about potential fatalities and serious injury. So, things have evolved, over the last 35 years, to say the least. So,
very simple change in dynamics, Tom. On a 12-volt vehicle, you're going to get a big shock. On a 60-volt plus vehicle, you're going to get electrocuted, and there are no two ways around that. That's the science of electrification of the motor vehicle. Yeah.
So my point is probably, you need to know what vehicles are coming onto site, and that starts with potentially the receptionist, and then that receptionist will then kick in a chain of events, potentially a driver going out to collect the vehicle or a recovery driver going out to get the vehicle, and they equally need to know what risks they're walking into, and whether that vehicle is a full electric vehicle, a mild hybrid, or a strong hybrid. And the hazards associated with that. So, the learning of today is all this information will be available on the NBRA website. So you can use this to show awareness to staff. That's awareness for all. Let's move on to the safe working knowledge of technical. And, who would like to take this one on?
Well, I can take this one if you like.
Go on then, Jerry.
This is normally the technicians who are called upon to get more involved in the high voltage vehicle. Under certain circumstances, they may even be expected to be able to shut it down to make it safe to work on, but normally they need greater awareness while they're working around this vehicle, and there would normally be in the company 2 high-level trained HV people, specialists, who would do the shutting down and making safe of the vehicle.
See, Jerry, on this one, I think it's more to do with the technical type of people you got in the workshop working on that vehicle.
Yeah.
And I understand the sentiments you're trying. Sorry, Dean, did I interrupt you?
No, I was just about to come in and say, completely understand. Jerry's on the next level of training. This is about panel technicians, paint technicians, multi-skilled technicians, people who are going to be working on the vehicle, but not necessarily on the high voltage system.
That's right.
They need to have the knowledge and have the experience to be able to understand the hazards around those high energy electrical systems.
Yes.
They also know how to be able to identify the component parts of a system and ensure those component parts are safe before they start to carry out their work.
Okay. Everyone comfortable with that one?
Yeah.
So high voltage technical competence, then, this is the highest level that you can get to. This is for all of us to discuss, but potentially this is your trained technician taking off, removing, replacing high voltage components. Is this just for the MET technician, or is it for Steve? How do you see this?
This is usually gauged towards the person that is doing the safety shutdown and reinstate as well. But obviously they may be required to replace components rather than shut down and reinstate the vehicle. So much higher level.
Hello.
Go on, Jerry.
I was going to say that would normally be associated with a level 3 qualification, and most companies,
sorry about that.
Most companies would train at least 2 people at this level so that they could cover absences. The idea is that these people isolate the vehicle and take away the key component that activates the system to isolate it from the vehicle, so that nobody can accidentally reactivate the vehicle while it's been worked on.
Yeah.
So this is a very responsible position.
Okay, so if this were to be a level 3, then what about level 4 and 5? Because vehicle manufacturers are looking at levels 4 and 5, and they're looking at, you know, potentially getting involved in the batteries at a higher level and a higher level of diagnostics as well. So I think there is a level 4 coming out into the industry, if not already there. And vehicle manufacturers are also looking at a level 5 as well, because you can see that in vehicle manufacturer methods. When do you think there will be a requirement for body shops to get actively involved in these higher levels of training and exercise within the body shop?
Well, at the moment, level 4 is normally only delivered by manufacturers to their franchises, to their master technicians, for them to enable greater in-depth diagnosis of these systems on the HEV vehicles. And of course, level 5 is an even higher level, and there will be very few people trained to this level because it tends to be training to a specific manufacturer. At the moment, this is the way it seems to be working at the moment.
Yeah, any other differing views on that? Or
the difference between level 3 and level 4 is that level 3 is the removing and replacing of the high voltage component in a non-alive state. In other words, the system is dead. With the removal and replacement of a battery, that is a life state. So that's why we have the level 4.
Yeah.
We're actually removing the components in a life state.
yeah, Pat, we've got a lot of feedback coming through your microphone, mate. We've got a job to hear you, unfortunately.
Will you switch to Bluetooth a minute? Yeah. Okay. Is that better?
Yeah, that is better. So, okay.
You're picking up on it so that you know. Did you get the business? You understood what I said, or not?
Yes.
Yeah, we did. But you know, in an industry where, you know, a lot of the work coming through body shops is, or, you know, the work provider is an insurer, and they would like the skill levels to increase within the body shops to make the repair quicker, and obviously to contain costs, but not at the jeopardy of safety, may I add. So you can see it all the way along the body shop revenue stream, where if you've got a hybrid vehicle with a battery in the boot, and that battery is damaged somewhat, if you were to train your staff to a level 5 in years to come, then potentially you could repair that battery and put it back into a state where it would be working after the event of an accident and reduce costs. That's where I think the levels will probably go in the future. And I'm just wondering, is there a time length before the body shops are expected to get there? And, you know, this is a hypothetical question, obviously.
Tom, I'd focus in on, you've just done a poll earlier on. I think I think right now for the body shops, the challenge to get to level 3 is strong enough. And I've seen body shops go to level 4, and then ask themselves the question, why did I just do that? Because fundamentally, I'm not allowed to use that expertise that I've just invested in. I think level 4 and level 5 is some way off the journey for body shops. I really do.
And that's the answer I wanted to.
Yeah.
Thank you. Yeah. Okay, we're going to go on to our. Is everyone okay on that slide? Any more information you want to depart or impart rather?
No, it's okay.
Let's go on to our next poll then. Shelley, if you could get the next poll up, please. So first question, who needs EV training? So tick the boxes that you think, and we'll look at the answers. And then, do you require specialist tooling to work on an electric vehicle? What is the typical cost of investment for a mid-sized body shop to be compliant on working on EV vehicles? So the cost we're looking at is training, and would it be under £3,500, between £3,500 and £5,000, £5,000 to £7,500, or above £7,500? Seconds just to get your answers in. Okay, do we have the answers, Shelley? Okay then, so METs, massive, VDAs, 95%, paint techs, yeah, panel techs, yeah, reception admin staff, 82%, I'm pleased to see that. Recovery drivers at 95%, absolutely on the money. It's everyone needs the awareness of the EV training. Do you require specialist tooling to work on EV? 93% yes, not sure. Yes, you do. What is the typical cost of investment for a mid-sized body shop to be compliant working on with EV? £3,500 to £5,000 at 43%, £1,000, 23%. Well, we've worked out to be around £4,000 to £5,000 for training and equipment. So some strong indicators there. So next. So talking about that investment, cost of training and tooling for a medium body shop to be compliant is £4,000 to £5,000. The cost of subletting for a discharge and making a vehicle safe is approximately £100. So, you know, the average is £50 to come in and discharge the vehicle and make it safe, and another £50 to put some energy back in the vehicle and bring it back online. That's all very well and good. But if that sublet technician gets into trouble while he's doing that, who else is trained at the body shop to be able to help him? Bear in mind, you've got that daisy chain effect. You know, you go to help him, you create a problem, because then you are now involved in that problem. So this is the awareness that needs to be in the body shop. So if you take an average of 30 minutes to complete the process, which you're subletting on an EV vehicle, the return on investment would probably take you about 250 jobs to get that back. Now that seems like an awful lot of jobs, right? But when you look at the rate of EV vehicles being sold in the UK, it shouldn't take that long. So the volume of EV vehicles coming into body shops set to increase, bearing in mind 28.5% of all the vehicles sold in 2020 had an element of EV. Now, I think someone else has got some statistics on this if they'd like to join in on this.
Sure, Tom. I can confirm that there's approximately 12.5% of the total car park is now electrified.
Yeah.
Just under 5% of that is full electric vehicle, battery electric vehicle, and around 7.5% to 8% of that is hybrid of some form, plug-in or self-charging hybrid vehicle. So that's a lot of cars, Tom.
Yeah. That's a rapid rate of knots they're coming into the industry. Oh, that went. But from 2019 to 2020, there's a probably, you know, nearly a 25% increase on electric vehicles from the previous year, and that's growing rapidly. So, you know, approximately 1 in 4 vehicles in 12 months' time will be an electric vehicle, probably coming into the body shop. So the volumes are increasing. I think our message here is that you need to think about future-proofing your business and start to comply with EV requirements. And, you know, if you're frightened of the EV vehicles, which some repairers may be, and they may not want to undertake that work because of that problem and that risk element, then, you know, you need to potentially look at investing in safeguarding your staff and becoming comfortable with working with EV vehicles, because, you know, it's something that work providers will probably want to mandate moving forward to make sure that they're putting that vehicle into a safe environment for that vehicle to be worked on. Now, the statistics on this sheet are purely the MBRA statistics, and it's not from Thatcher, and it's not for Training 2000. So I think the key message to walk away with here is you cannot quantify life, and no matter how many statistics we put on this sheet here, take the necessary steps to safeguard your employees and your business, because you won't get a second chance if it goes wrong. So it's not just cars. Light LCVs are coming into the market as well. You've got more commercial vehicles that are going to be EV, and you've only got to look at some of the vehicles on here, and it's thanks to Auto Express for the image that you've got the Vauxhall Vivaro that's coming out at a rapid rate of knots, the VW Transporter, and these are common vehicles used by Amazon, for instance, and the fleets they're going to be looking at. So I know it's quite commonplace now for a group of repairers to have a dedicated LCV centre, which will have to focus in on these to make sure they're compliant and they're keeping their own. Jerry, how do you see EV from the VBRA?
EV, commercial vehicles, is a problem that is with us now. Volkswagen Commercial have a full approval program in place. Mercedes-Benz Van have a program that they're working on at the moment. All of the other major van manufacturers are feeding in vehicles, including Ford with the Transit. This is with us now. The similarities between working on a light commercial vehicle and the cars are very, very similar. The requirements are all the same. You cannot escape from this problem. It's there with us now, whether you're working on a light commercial vehicle or a car. So this is going to spread into our commercial vehicle body repairers. It's going to also be a problem for our bodybuilders. There's nobody's going to escape from the requirements to have awareness, knowledge, and skill.
The problem's not going away, it's getting bigger, and it's not even a problem, it's our future.
That's right. So,
now then, hydrogen, the future, potentially. I think, Dean, you've got quite good knowledge on this, and so have you, Steve and Pat. I think it was illustrated earlier that it's not the simplest of technology creating an electrical charge from hydrogen, but the infrastructure of the rest of the vehicle is very similar to an electric vehicle. Dean, you were sort of elaborating on this earlier, weren't you?
Yeah, the only major difference in this vehicle that you can see from the illustrations of the earlier vehicles is the hydrogen fuel tank. The fuel cell stack is slightly different, but fundamentally it's still a high voltage vehicle. Biggest challenge for repair, and actually it's probably better regulated than the introduction of pure electricity, in the fact that we've got the pressure vessel regulations protecting that fuel tank. And from a safety perspective, hydrogen cars are regularly now getting 5-star Euro NCAP ratings from the crash test. So treat them with the same amount of care and attention. Special training will be required if you're going to be removing and replacing any component of the hydrogen system.
Yeah.
But don't worry yourself with how you turn water into atoms, because that happens inside the system and you're not going to be opening up.
No. So you haven't got to be worried about sitting on a hydrogen bomb if someone hits you in the rear.
Hopefully not.
No. Okay. And it's good to know that they have been crash tested, because, that's not obvious to the rest of the industry either. So, technology is moving on. I think it was Mercedes that had an Olympic swimming pool when they were looking at this type of technology, just in case it went a bit pear-shaped. So it's good to know that, they have NCAP crash testing. Jerry, from a commercial perspective on this, you get to know that JCB, they're adopting hydrogen for some of their diggers and plant equipment. How do you see this rolling out for VBRA members? And
Nobody quite knows the limit of the size of vehicle that you can use hydrogen on.
Right.
It's generally accepted that you will be able to use electric vehicles for up to 16 ton. But over 16 ton, you're looking at the alternative fuels such as hydrogen, compressed natural gas, and liquid natural gas. And obviously they bring a different set of problems. And it's all about knowledge all the way through, awareness and knowledge.
Yeah. So, I mean, yeah. So there's more and more heavy goods vehicles that are probably going to adopt hydrogen. I mean, they're even adopting this to airplanes, and they're trialing it with airplanes as well. So, you know, I think if I wanted to get in a hydrogen car tomorrow, then, you know, my local hydrogen station is probably in Swindon, which is about 35 miles away. So the infrastructure is not quite there yet. I do know that there are various fleets and hire car centres that are having to take on hydrogen vehicles. So they will be being seen in and around the areas. So anyone else got anything to add on hydrogen? No? Well, let's go to the Q&A then. We've got a couple of questions that have come up. So Andy, you've asked level 3 is HV de-energized, level 4 is HV energized, level is available via training providers, not just VMs.
It is.
There you go then. Thank you very much. Anonymous, can anyone advise the end-of-life solution and environmental impact of the batteries?
Well, I can tell you that Nissan in particular have invested millions in the reuse of batteries that are no longer up to scratch in their efficiency in motor cars. And these are being developed into units that can be placed in housing, offices, etc., etc. They will be supplied from solar cells on the roofs of the buildings, and these batteries will last for several years onwards from being in a motor car. So, you know, they're not just going to be thrown away or sent to landfill. That's not going to happen.
Okay. Dean, sorry?
Yeah, it's the life of a battery to power a vehicle. You need it to be about 95% of its capabilities. Once it falls below 95%, it's probably not got the necessary capability to power a vehicle. However, as Jerry says, it does have the ability to store and transfer energy in construction and building industry. So they are very recyclable.
Okay.
Yeah, thank you, Dean. Mac?
If you look up a little island in the Atlantic called Porto Santos, you can see everything that you've all just said being put into practice. So if Anonymous has a look on the internet and searches Porto Santos, he'll see exactly what you've just said.
Right.
How the batteries are being recycled, because not every cell is dead in a battery that's been removed and recycled.
No.
Some of these can be reused again. So this is what they're doing with some of these. Doesn't work too well in Lancashire for the sun, but some of these other islands, you know, that have lots of solar panels that can recharge these batteries, can be used for household use, you know, like you've all just said, you know. So there's another technology besides, you know, just looking at hybrid power for other things with the battery cells themselves, you know.
Yeah.
Thank you, Pat.
It's incredible that Nissan have created with the local governments and councils round about the northeast a whole new infrastructure to use these old batteries for the heating and lighting of homes and offices. It's incredible.
Yeah.
So we're running out of time, gents, so we're going to get through these questions. Matthew Cooper, have insurance companies engaged? Chris Weeks has answered that one, if you will care to look. Michael Reed, can we uplift the labour on EV to say £50 per hour to pay for investments required? I think that's been answered by Chris Weeks in engagement with insurance companies and other work providers, because it's not just insurance companies that are feeding these types of vehicles into body shops. Darren Blackmore, can we see more webinars on this subject, please, as information is thin on the ground? Absolutely, Darren. We were discussing that earlier on today, that there's probably going to be a second edition of the webinar on EV. And as I said, there's an awful lot of information to try and get into this webinar. So if you want to use it as a taster, brilliant. We'll do a more in-depth webinar later on, but we will be putting more information on the MBRA website under the technical page for you to have a look at. Richard Thurgood, is there a view from a panel as to the potential impact of increased total losses due to the cost of battery and electrical components, and in turn reduced actual physical repairs moving forward? Who would like this one?
Oh,
Go on, Dean.
I don't think there's enough data yet to
No,
establish
there's no answer.
whether that's fact.
No, but I think it's obvious at the forefront of this. The components are quite expensive at the moment. Some of the placement of these components are risk averse to an impact. So I think what Richard's saying, it's obvious that the cost of AD costs will go up as a result of more of these coming into the market. But I know that, you know, Thatcham have challenged certain prices on components where they see them out of ilk. Matthew Cooper, has the VBRA engaged with any tool suppliers to leverage discounts on tooling? Yes, we have, and yes, they are, and they will be going onto the MBRA website with suppliers that are members. Leon Bosch, is the MBRA or similar working with motor trade insurers to help them better understand the risk, in that they view involvement in EVs as a major hazard unless a main dealer, which is impacting premiums for repairers? I guess for this one, it's probably not the MBRA that are upskilling and making awareness to motor trade insurers. It's potentially, you know, Thatcham have an awful lot of insurers on their books that get an awful lot of this knowledge. But we'll look into that, Leon. Any other questions? I think that's it, and we are out of time. So, Steve, thank you very much for your participation. Pat, thank you.
Pleasure.
Yeah, eventually, just in time. And Dean, thank you for coming on today as well. And Jerry, as always, impeccable. Thank you all for attending today, and look out for the next webinar, and have a great day. And this will be on the MBRA website. There will be a recording of the webinar and a copy of the presentation. So thank you very much, and see you soon.
Thank you.
Thank you. Right.
Cheers, everybody.
Bye-bye.